Now, one major difference between the PIM dense mode and the sparse mode is the way it forwards the traffic. Now, in case of dense mode, it's going to flood the traffic out of all the ports, means all the devices is going to flood. It's going to work with flood and prune. That's what we discussed. Where once it is flooded, all the routers comes to know about that source address. Like let's say the IP address of this server is 192.168.1.1, and it's going to maintain the group address. And the group address, let's say it is 224.5.5.5. Now each and every device is going to maintain this information on how to reach the server, and probably this router also knows how to reach the server. And if this particular router do not have any host who wants to receive the multicast traffic for this group, it's going to send a prune message. But each and every router here knows or exactly maintains S, G entries where how to reach that particular server if they want to receive the multicast traffic for this particular group. Now that's what it uses something called shortest path to reach that particular server. And this method of this tree or the forwarding path which is built, we call it as a source tree. We call this as a source tree. Now source tree is the one which it uses the shortest path from sender to receiver based on the flood and prune behavior, which generally happens in your dense mode. Now in case of sparse mode also it's going to use the same way, but in case of sparse mode, if you remember, we discussed that it's not going to do flood and prune. Instead they are going to register with an RP router, and the multicast receiver will join with RP, and whereas the server also is going to join with RP, and the RP is going to maintain the information about both the sender and the receiver, and the RP is going to provide the information how the forwarding has to go from sender to receiver. Now in this kind of scenarios, initially the traffic will be going from the source to the RP, and the RP will send it to receiver, and this forwarding of the path or the tree which is built here, we call this as a shade tree. Now shade tree, in simple words, we can say it's via RP, whereas in the source tree it's going to be, is it a shade tree or source tree? Yeah. So the both look similar, So if you're using shade tree, probably it's going to be via RP. When you say source tree, it's going to directly go from source to the receiver without any RP. Now initially, if you're using sparse mode, initially the traffic is flooded via RP. It's going to go via RP, but later on, once the receiver knows the source address, probably it uses the shortest path. So if you're using sparse mode, it's going to use the shade tree initially, that is via RP, and then later on it's going to build the shortest path and it uses source tree. But whereas in case of dense mode, there is no RP, so probably it's going to flood traffic where every router is going to maintain S, G entries. Now that's a major difference between how the forwarding happens in the dense mode or the sparse mode. Now the dense mode generally uses only source tree, whereas the sparse mode, it's going to use initially source tree, later on it's going to use shade tree, later on it uses source tree. Now the major difference here, shade tree means it's via RP here. Now the shortest path from sender to RP and from RP to the receiver, and it works only in the sparse mode because we have a RP configuration only comes in the sparse mode. So one of the major advantage in the shade tree is it's going to eliminate the flooding and the pruning and makes much more scalable. So probably in the production networks we prefer to use sparse mode, which is most commonly used. And this sparse mode initially it uses source tree, and later on it's going to use shade tree. Now the modes are actually the way the forwarding happens in general, but the actual forwarding, like the tree. Now here the forwarding mechanism we refer them as trees. This source tree and trade tree is just a mechanism which it uses, but the actual modes which they operate, we call them as dense mode or sparse mode. Now probably in our next sections we'll try to get into more in detail on how the actual forwarding happens here. Like here, just now I discussed the source tree, it just uses the shortest path because all the routers knows the shortest path to the source, because it's going to work based on flood and prone. Whereas in case of shade tree, it goes via RP. Now if you compare these two trees, probably the advantages of the source tree is it's going to use the shortest path from source to receiver, but whereas the shade tree, it's going to it goes via RP. So which means it is not it carefully we need to consider the RP, because the path between the source and the receiver may not be the best path, because it is going via RP if you do not place the RP properly. Now, but the disadvantage is, the additional overhead, because the router has to maintain the path information for each and every source. Now, whereas shade tree lowers the overall memory requirements here. But at the end, we use commonly the sparse mode, which uses initially it uses the source tree. Probably later on it fall back to the shade tree via the shortest path. Now first it uses the shade tree initially, later on it fall back to the source tree, the shortest path here.